All right, this is a story that's rapidly unfolding. So I was doing research for this other video about fractals when I came across this algorithm called iterated function systems. This algorithm is used for drawing fractals like the Barnsley fern. And I had this huge epiphany that I could use these algorithms to create fractals in a way that looked more organic. So I had to drop everything I was doing with that video and pursue this for the past couple of days. So let me show you what I was able to make so far. I generated the data in Python and then I figured out how to use Cinema 4D to plot it. For anyone interested, I'll put a link in the description to my GitHub repository if you want to work on this. So really quick, iterated function systems work by taking an initial object and applying a set of functions to it. These set of functions basically take the initial object and make shrunken copies of it. And then by applying this set of functions recursively to this object, you get something that looks like a fractal. So the epiphany that I had was that we could take something like this, but add some randomness to these functions so that the final result that you get looks more organic, like it's something that was like grown. The Barnsley fern is made using this set of algorithms. I was like, even that Barnsley fern is too regular, right? I want something that looks more like a fractal Frankenstein here. So the first experiment that I did looked like this, where you start with this seed object and then you get 4 children, and then for each of those children you get 4 grandchildren and then 4 great-grandchildren. So obviously in this case you're applying the same set of functions at each generation, and in 3D it gets you something like this, which looks like the Sierpinski triangle. But then I was like, how can we start to mix this up? You can think about applying a different set of functions at each generation and for each child. So in this case, all the children are identical. When I did it in 3D, it looks kind of like this. So you can kind of see how definitely in that first generation, these 4 identical blobs, and you can see these clusters of these identical blobs. And that already is giving us something which looks really interesting. But I wanted to push this further. I was like, how can we make this look even more organic? So here's the final version that I came up with. Cinema 4D allows you to control many different properties of an object, and in this algorithm I focused on changing the position, the shape and the size, the color and the rotation of these objects. You actually have a different function for each child. The function that's applied to each of the parent objects essentially mutates it by making a slight change to the shape and size, the color and the rotation. So you end up with these branches that are more homogeneous. So it's not just a bunch of random colors. Like within a branch, you have some color and shape similarity. We're even adding randomness here to the number of functions. So each parent may have a randomly selected number of children between like 3 and 8 or something. And so then you run this algorithm for like 5 or 6 generations. You get some pictures that look like this. And so the final step that I applied just for fun was to put it through a style transfer algorithm called Prisma that allows you to kind of apply certain painterly effects to it using deep learning. And I got some really, really cool results using that. I'm really glad that I figured this out because I had been looking for a way to plot data using a more sophisticated renderer like Cinema 4D for a long time. And so this code will allow you to do that. If you happen to have Cinema 4D, then you can use the code in that GitHub repository. So the way that I've set up the program allows you to control these high-level parameters that control the way that these things grow, the process of growing them. For example, how many children do you want each parent to have? How much do you want the color to change? How much do you want the shape to change at each generation? You can start to grow these kind of like virtual organisms by changing those parameters, you can change the way it develops, and you can change the overall, the final look of it. I hope you enjoyed that. Thanks for dropping by. I'll see you next time. Peace.